So these two slopes here, this one, they were my students in my freshman seminar a couple of years ago. Last year. And somehow I found out that they play and they sing. So they have done this for quite a few times. And I'll let them talk to you about their music club. This is not just for having fun tonight. This is about purifying the mind. Your parents invested a lot of money for most of you to learn something to play. And now you will forget about it. Don't forget about it. These two girls and that boy there is to remind to you that you can use it during college to maintain balance. Otherwise, when we lose balance, then we lose everything. Okay? So they will go and play about 5-6 minutes and sing, and then Rudy, your own classmate, is going to sing and play also music himself. Okay? So how about if you go and introduce yourselves?
My name is Yuan, like Yuan.
Freshmen are in the house. We're actually second years, but go freshmen. So I hope fall quarter has been treating you all well. Here's my email. So I wanted to talk to you guys about this club that we're trying to start up again. It's called the Music Club that I formed like end of last year, and we were kind of inactive. So we're still a really new club, and ideas being thrown at us as to what we want to do with the club are more than welcome, because we're still kind of at a we don't really know what to do with the club stage. So email me if you're interested, if you play a musical instrument, if you want to hook up with a network of musicians, or if you just want to check us out, email me, and yeah. What's so funny? Am I saying a lot? Okay. Okay. So, Professor, is it okay if I sit on this table? Is it okay if I sit on the table? How many of you guys went to the gardens? Yes. Check out the gardens. It's a good idea.
Back down where all come for me.
I'm going to sing Imagine by John Lennon. I'm not a good singer, so don't feel bad if you laugh or something. And sing along if you want. Imagine there's no heaven. It's easy if you try. No hell below us. Above a sunny sky. Imagine all the people living for today. Imagine there's no countries. It isn't hard to do. Nothing to kill or die for. And no religion too. Imagine all the people living life in peace. You may say I'm a dreamer, but I'm not the only one. I hope someday you'll join us, and the world will live as one. Imagine no possessions. I wonder if you can. No greed or hunger. Brotherhood of man. Imagine all the people sharing all the world. You may say I'm a dreamer, but I'm not the only one. I hope someday you'll join us, and the world will live as one.
The story now. Maybe now you can read a story that is bigger. I will always show this story every quarter to my students. And the reason is, almost hardly anybody is asked, what are you going to do? And everybody wants to become a medical doctor. We need medical doctors to become medical doctors because of compassion. The so-called Medicare is not going to change unless we have doctors that they are there because of compassion. Not because of parental influence, not because of glamour, or because of promise of high earnings. We want medical doctors to be compassionate. And I want the students to think about it. 1 week ago, I was giving this workshop for 4 hours on Sunday. And there was a sweet man who came up and said, thank you very much because you reminded us today why I want to become a medical doctor. Because everywhere I went, from the lectures that I was listening for a whole 2 days, it was said to us how to become a medical doctor. But I did not hear for a whole 2 days why I want to become a medical doctor. And he said, I thank you very much, you reminded to me. And I believe that kid is going to become a beautiful medical doctor. There's so many other occupations that you can do and I can do. But that occupation has to be reserved for people that have compassion. That's what the kind of doctors we need, each one of us, me and you. And if we don't do it ourselves, it's not going to happen. So that's a beautiful story I found in India this summer when I was visiting for a month there at Amrita University in a booklet. And actually I used this for a speech I gave there to the first year medical students, which I'm going to send to you as a YouTube. One of my past students spent many hours to put together the speech with some slides all together on YouTube. Spent many hours. Jonathan, the president of the student tutoring students, he did that all word for word. So I'm going to send it to you in a few days when it's going to be ready. I will send it to you. And I want you to listen to it. If you want to become a medical doctor, you should listen to that talk. I hope you will. Okay, so let's do some more problems. One kind of problem that looks like kind of, it's very classic problem, but it's kind of funny because it could be confusing, but it shouldn't. So, there are different substances. Huh? What's that? Oh, sorry. Yeah, it gives you different, it gives you the same quantity, right? 5 grams, same quantity. But they're different substances, right? From these substances, they are all molecules except one, and actually, right, they're all molecules except one. And there is, from these 5 cases, there is total how many elements? How many elements? You see, the problem is very classic. It's in many books, right? It's a very classic problem, used problem everywhere. But immediately, these very fundamental questions are asked, right? And this shows if you really understood so far the concepts. All these choices A, B, C, D, it gives you 5 grams. Immediately you should know that all these cases talk about the same what? Quantity. Not amount, quantity. You have the same quantity in grams or kilograms or pounds or AMU. It doesn't matter what the units are, the same quantity. But it doesn't mean you have the same number of particles. Yes? Because it depends how big each particle is. Then the other question we ask for the problem is, how many elements do you see there? And you can see people are asking. Some people say 5, I mean 3, 4, I mean all kinds of answers. That means if you do not give the correct answer, how many elements are there? Imagine, now this gave me an idea actually for next quarter, whenever I teach play again. you give this problem with this kind of question. How many elements are there? How many? How many elements do you see there? 3. Okay. Okay, so we have 3 elements, right? So now we want to find out which one has what, the largest number of? Largest number of atoms, right? So somebody could look at it and kind of being confused, right? Which one is the answer? And how did you find it, actually? Which one do you think it is the answer? But why? Okay, why? How do you do it? How do you do it? Could you show it with the equations? You see, let's do it, huh? So, number of moles, right? Number of moles is equal to the number of atoms. The number of particles, let's say particles, right? Divided by Avogadro's number, right? So number of moles of particles, particles. Number of moles of particles divided by Avogadro's number. Yes? Also, this number of, if you put in number of moles, right, is equal to mass in grams divided by molar mass, if it's molecules, atomic mass, right? These are 2 equations that you really have to have in mind, right? Number of moles is number of particles by Avogadro's number, and number of particles, and number of, what I'm saying, number of moles of particles, number of particles divided by Avogadro's number, right? This is number of moles. Again, the number of moles is mass in grams divided by molar mass in grams per mole, right? So, if you just take one, and then you can make a rule, you remember it, but it's just take one, let's say chlorine. Let's do for chlorine, let's say. It doesn't matter which one, right? So you have what? 5 grams of chlorine, right? And you want to go and find out how many atoms, right? Okay. Any one of them to find out the number of atoms. I mean, the longest way will be to calculate the number of atoms of each case. You know, if you do that, you're wasting a real 10 minutes for just a code that can be done really fast, right? So you just have to day one. In fact, if you've done it at home, then you know immediately where to look at, because you know what's happening. And you don't even have to do any calculation. Immediately you can say what it is, if you've done the problem before. So let's do one only and we'll see what it will come up with, right? So we have 5 grams of chlorine, we want to know how many atoms of chlorine, right? So go from grams to atoms, we use the concept of mole order, right? So grams of chlorine has to go out because I want atoms of chlorine. So through moles, okay, moles of chlorine. So what's the relation between these two? 1 mole of chlorine, Cl2, will be 2 times 35.5. Okay, I'm at moles of chlorine, Cl2. But I don't want that. I want to have down here, that has to go away anyway, so let's put it here. Right? I want to go to atoms. So 1 mole of chlorine atoms, how many atoms does it have? Na, Avogadro's number, right? Atoms, chlorine. Okay, so this goes away. So now I have atoms of chlorine. Oops. Yes, that's what I want to be on the numerator, right? That's what I want to find out. So we have 5 grams, 1 mole of chlorine per so many grams of chlorine too, okay? And then we have Avogadro's number atom chlorine per 1 mole of chlorine of C, no. This is true, right? If we have this, right? So we have to write it again, otherwise it will be confusing. Okay? I don't want you to be confused, so we're going to write it again. We can correct it, but it's okay. I think it's better to do it again. Okay, 5 grams of chlorine. I want you to see how you think. Okay, so here we are. We said the first thing we do is what? We don't want grams of chlorine, so you put it here. CO2, right? We want this out. And we go from grams to particles through moles. So 1 mole of the same thing. How many grams? 2 times 35.5. Okay. Now, I don't want this because I want atoms of chlorine. So if I don't want it, I will have to put it here. And I want to go to atoms, so I have something that relates to atoms. 1 mole of chlorine 2. How many moles of chlorine atoms it is? Yes? So that will go away. And now we're ready to go. I want atoms of chlorine. Atoms, chlorine. I have now what I want, but I don't want this. Moles of chlorine, I don't want it. So 1 mole of chlorine is how much? I've got the number of atoms of chlorine. So everything is gone and I have the units I want. This one here. So it's actually what? 5 times 2 times Na divided by 2 times 35.5. Basically what you come up with is 5 Na divided by 35.5. Right? You did only for one, not for everyone. Just did for. And what do you see there? What do you see? You see that it is a constant because Na is Avogadro's number, is a constant. The 5 comes from where? From the 5 grams, yes? So for everyone is 5 grams, Avogadro's number. So for every case, you will have the same numerator, yes? Observation. So if you want the largest, you want to have the smallest atomic mass. And you choose from all of them which one has the smallest atomic mass. The hydrogen. But you have done so. So if you have done this problem, you remember the number of particles, atoms, is inversely proportional to the atomic mass. You see? If you don't remember it, you don't have to do for every one of them and say, oh, this one, because you're wasting so much time. You just do one time and then you observe it. Observe it. That 5, everyone has it. So it's going to be, if I do something else, I still will have that 5 there. Avogadro's number is the same, so the only thing will be different for every time will be what? Okay? What's that? Well, if you have to show the work, you need to do it. If the problem tells you to show the work, you have to do it. But we have 3 sections, right? First time you do it. Probably you have not noticed if you've not done the practice exam, right? The first section is concepts, multiple choice. The second one, you have to do work, but it's multiple choice. You don't have to show anything. You won't get any credit anyway, if you have partial credit, in other words. And the third part, it's about 1/3 of the exam. Even if you make mistakes, but you have different parts correct, you don't lose all the problem. You lose a few points here and there, but you get credit for your work, right? So that you should know. So then you start which way you really feel like. Some people like to start from the concept, some people feel like to start from part 3 because they get tired and their mind doesn't work. So if I was you, I would start from 3 because after your mind gets tired, you will be able to do the problem probably with a number. But each one is different, right? Each one is different. You can make rules, right? Some people like to start with part 1, some people start with part 2, some other part 3, part 2, 3, whatever. Okay, let's do this problem here. This is an old organic exam actually. It's pretty funny. I saw something there. Maybe we can do it. Let's see. No, that's big. Where is it? There. Okay. Let's do this one. Let's do this one. Doesn't matter. Let's do this one. Okay. So what's the molecular formula? It's a hydrocarbon. That's from an exam that I gave probably a couple of years ago, or maybe a year ago, for my 118A. Probably second exam or something. So let's do this one. What's the molecular formula? It's a hydrocarbon. What's the molecular formula of this hydrocarbon? Okay? Try to do it. What's the molecular formula of the hydrocarbon? Try it. Did you do it? So the rule is every corner and every end of a line is what? A carbon. So you have 5, 6. Hydrogens, how many hydrogens? Each carbon is supposed to have 4 valence, 4 lines, right? So the missing ones are hydrogens. So here you have 1 carbon, 1, so how many hydrogens here? 3 hydrogens there. How many here? 1, how many here? Right, 2 here, 1 here, and 3 there. So it's going to how many? 12, right? Am I right? Yes. Yes, that's correct. Okay? So that's pretty easy. But you see, when you go to organic, you will write all these structures, it doesn't matter how complicated they are, you will write them like that. You see? Look at this. Can you see them? Oops. You will write organic chemistry structures all the time like line structures. More complicated, whatever. But this is kind of a start, right? Okay, let's go another problem now.